Was Mars ever suitable for human habitation? Has extraterrestrial life ever existed on this lifeless planet? Or more importantly, will mankind colonize this red, deserted world someday? These inquiries have been made repeatedly ever since the first space probe touched down on the surface of Mars, and more so because the planetary discoveries on Mars, in contrast to Venus or Jupiter, have frequently proved that the red planet was once crowded with living organisms and plenty of blues. So tie up your seatbelts and smash the like and subscribe buttons as we're about to begin the journey of Martian discoveries. The red planet's explorations have been the most significant quest for astrobiologists at NASA, as not only the planet has shown significant signs of life, but has shown marks of liquid water presence and has indicated the formation of compounds and compositions that are only found on Earth. But astonishingly, the data received from the deserted planet this time has set the planetary research bar tremendously high. Yes, the recent findings on Mars have predicted that Mars was once able to sustain life. The most sophisticated rover sent to Mars to date has lately shown clear signs of past microbial life on Mars, and scientists are now optimistic that they might find actual traces of life very soon. Under the Mars exploration program, numerous robotic spacecraft have been sent to the red planet. However, not a single one of them was well-equipped or specifically built to search for indications of life. But ever since the Curiosity rovers went to Mars and brought the news that the planet was exactly like Earth 4 billion years ago, the Spirit rover returned with evidence of old waterbeds. It became essential for NASA to design a robotic spacecraft aimed just to find life on the planet. So this time, NASA was particularly interested in finding data that offers solid and unambiguous evidence that the planet had life in the past. Following all of these successful past inspections, scientists carefully planned the Perseverance Rover, which was wholly equipped to detect traces of life and was built in consideration of Martian surfaces and harsh environments. Amidst COVID-19, NASA's most advanced and scientifically sound rover, Perseverance, was launched into space on the 30th of July, 2020. After the protracted and exhausting space voyage, the rover finally landed exactly where it was supposed to on February 18, 2021. The rover alighted on the land of the Jezero crater, the famous lakebed of Mars, which, according to scientists, was the most suitable land to find traces of microbial life. As per NASA, there were many craters on the land of Mars that could have hosted water bodies. But the Jezero crater, amidst all those, was one lakebed that showed clear evidence of water presence. This crater, unlike others, had a clear inflow and outlet channels for water and had a long surface area that had similar delta deposits as Earth. So, as per scientists, the crater seemingly has a great mineralogy and was an amazing place to find microorganisms. Brad Garciniski, a student of PhD and planetary scientists about Jezero crater, stated that if microbial life did exist here in the past, this is one of the best places to look for it, as finely layered muds may have buried and preserved a record of that microbial activity. The Perseverance rover, in addition to the Curiosity rover's equipment, had various scientific equipment that was essential to finding life. The remarkable rover was equipped with an X-ray spectrometer, a tiny weather station, a laser microimager, subsurface radar, and a MOXIE device to convert CO2 into oxygen. Moreover, the rover was equipped with 43 lightweight test tubes that were explicitly designed to collect and preserve the samples of sediments, rocks, and sandstones of the Jezero crater. The test tubes were built in a way that they could easily be drilled into the ground to extract samples from the inner layers of the land. Moreover, the most amazing part about the rover was its tiny little fellow Ingenuity. To avoid harm and traveling difficulties, the rover had its tiny little partner with him called the Ingenuity rover, which was designed to try solo flights on Mars. But since the Perseverance rover was equipped with self-driving technology, the Ingenuity rover was there to be its eyes when needed. So apart from various purposes of ingenuity, one of the prime purposes was to fly at a maximum height of 39 meters and find the right path for Perseverance to travel. In its first scientific campaign, Percy, or Perseverance Rover, collected 8 samples in total, amongst which one of the samples were quite interesting for the scientists. The rover found the famous igneous rock on Jezero craters called olivine. Olivine is an olive-colored rock that is usually found in places where volcanic eruptions have happened in the past. This rock is usually formed with magma in high temperatures. Roger Wiens, a planetary science expert, commented on the rock and said, "They are 1 to 2 millimeters thick, indicating that they were formed in a large underground magma chamber, yet they are currently at the surface." This discovery confirmed that NASA was heading in the right direction. Based on the data received, the crater was rich in mineral deposits, salts, and other organic matter. According to the experts, these organic molecules are quite a significant aid for the growth of the microbial line. However, the extracts obtained were all so diverse that the geologists speculated what else they may find on Mars. They also identified several rocks including robine, cordiae, Braid's Sol 254, and core. Among the samples collected, one was a meteorite sandstone, while the others were a mudstone, rich in diverse organic compounds. Dr. Amy Williams, a geologist and scientist at NASA, said that the Perseverance rover collected rock samples, representing diverse rock types present on the crater floor. In many ways, the landforms and the rock types of Mars are very similar to those on Earth. On Earth, microorganisms can live within igneous rocks and harness metabolic energy and water from those fluids that altered the rocks. Percy further retrieved a sample from the Wildcat Ridge, a 1-meter-long bedrock formed billions of years ago. So it's obvious that when these samples return to Earth, they'll reveal a lot about Mars that we didn't know before. According to NASA, the sample retrieved from Wildcat Ridge was perhaps the most peculiar of all the collections. So when NASA investigated the Wildcat Ridge using Sherlock, the camera equipment, they noticed that it was rich in sulfate. And the greatest part about sulfate crystals is that they can reveal a lot about the oceans wherein they formed. This was indeed terrific news for NASA, as bioactive molecules are composed of hydrogen, nitrogen, oxygen, and carbon dioxide. And all these elements are also found in the cellular structure of living organisms. This kind of evidence was also discovered on Earth a long time ago. According to the research, some 16 million years ago, an asteroid smashed into the surface of Mars, and due to the collision, a Martian rock landed up on Earth near Antarctica. The meteorite was called ALH 84001 and was thoroughly studied by geologists in 1984. Upon investigation, meteorite hunters discovered that the rock dates all the way back to 4.2 billion years, which was the time when Mars used to have liquid water. In his study report, David McKay, an astrobiology specialist at NASA, determined that the rock had a polycyclic aromatic molecule, which is basically a complex organic structure found in bacteria. Moreover, during that research, they also detected magnetite, a rare element that is seldom seen near carbonates unless microbial metabolism causes it to develop. Furthermore, during a microscopic analysis of the rock, scientists even discovered strange worm-like bacteria on the meteorite. And this was the first time anyone proposed the concept of microbial existence on Mars. But the finding was met with a barrage of differing ideas and arguments. However, with the latest finding by the Perseverance rover, it is clear that the discovery made by David McKay and his crew was nothing but the truth. The major issue for NASA now is to transport the specimens back to Earth without any loss or damage. For the time being, the materials are protected within the spacecraft in specially designed titanium tubes that shield them from sunlight and the thin atmosphere of Mars, which might change their composition. At this moment, ESA and NASA are collaborating to come up with strategies for securely returning the specimens to the blue world. The current goal is to land a sample returner armed with a miniature rocket onto Jezero crater. The rocket will then retrieve the sample and transport it to Martian orbit, where it will be recovered and sent back to Earth by another spacecraft. This seems like a difficult plan, but the agencies are meticulously organizing the event and have chosen to carry it out by the middle of 2030. Let us only hope for the safe arrival of Martian samples. That's all the time we had for Martian life discovery. So now let us know what you think of the previous microbial life on Mars, and what do you think of the specimen retrieval plan? Let us know in the comment section below, and subscribe for more content on the space developments.